Friends, welcome to my channel. My target 100%. I think all of you must have seen my last video, and that video was work, energy and power, and that is going on. You must watch the video completely and write the important points while watching the video, and every points, notes, KP plus PP notes, and any other extra points I have added after watching the video, okay, in the description box. And if you have any doubt, you put the message in comment box, okay. Anyway, today's topic is law of conservation of energy. Law of conservation energy. Before going to law of conservation energy, we should know about the what is energy. Energy is the capacity of the body to do work. What I told, energy is the capacity of the body to do work. Examination point of view, you must remember this one, that energy is of many types, but we are reading mechanical energy. Mechanical energy means that I have already told, the sum of kinetic energy and potential energy. The mechanical energy means total energy. All of you listen carefully, and at the same time, kinetic energy, work, potential energy, all are scalar quantity. Kinetic energy is by virtue of motion, half mv square. Potential energy is due to position, condition, configuration, and formula is mgh, and both are scalar quantity. Joule and arc, the SI and CGS unit of kinetic energy, potential energy respectively, okay. So at this time, while we are going to prove the law of conservation of energy, it is applicable only when a body falls freely under the action of gravity. For a free falling body, law of conservation of energy is valid, okay. So when energy changes from one form to another form, so it is known always constant transformation of energy. You may be add or remove some energy, but the total energy remains constant. So let us discuss law of conservation of energy. What is the statement? Statement is the sum total of energy in an isolated system is always constant. That is the statement. Explanation is the sum of total energy remains constant. However, the energy form changes. Energy can neither be created nor be destroyed. It can only change its form from one form to another form, one position to another position, one place to another place. But the sum of total energy in an isolated system in this universe is constant. That means if you are taking one part, one system, some energy is appearing. At the same time, how much energy is appearing at the same time in other part, the same amount of energy is disappearing. How much energy is lost, same amount of energy is gained. And you have also read that was the James Prescott Joule's law. Mechanical J, W proportional H, W is equal to JH, J is equal to W by H. That was the mechanical Joule's mechanical equivalent of heat. Okay, you have read. But now law of conservation of energy. It is the fundamental law of physics. It is applicable in all cases. Basically in transformation of energy, law of conservation of energy. Law of conservation of energy. You have to derive how that energy remains constant during a free falling body. Okay, let us discuss. Let us consider one body which is situated in this place at a certain height h. ये R surface है, body यहाँ है, suppose position A. While body falls, suppose body this one is B and this one is C. Total height of the body from the R surface is h. When it reaches at B, suppose this distance is how much? थोड़ा speed बढ़ा रहा है x, and from the C to B, height of the body from the ground it is h minus x. Total जोड़ दो x plus h minus x कितना हुआ? h हुआ. Total height h हुआ. Okay. Let us consider the three cases. So mathematical expression. Mathematical expression. So just I am writing, let m is the mass of the body, m mass of the body, okay. G acceleration due to gravity, h height of the body from the earth surface, or you can say the body is raised at a height h, okay. Now u initial velocity, v final velocity, or assume when a body falls at reaches at b, its velocity is v. Let us assume it is possible. We are considering 3 cases. You will see that if 3 cases total energy is mgh, so no doubt it verified the law of conservation of energy. Now I am erasing this one due to lack of space, okay. देखो बच्चे क्या हो रहा है, कैसे हो रहा है. Case 1 when the position of the body, at A, okay. U initial velocity कितना है, 0. So kinetic energy कितना हो गया, हाफ mu स्क्वायर, तो ये भी 0 हो गया. कौन सा बड़ी कहाँ है, m है. फिगर देखो, तो अभी पोटेंशियल एनर्जी कितना होगा, EP कितना होगा, mgh. बॉडी यहाँ है, मतलब mg मालूम है, हाइट ऑफ द बॉडी h, यहाँ से यहाँ तक हाइट h, तो इतना हुआ. सो अभी em इज इक्वल टू et मीन्स मैकेनिकल एनर्जी, दैट मीन्स टोटल एनर्जी, इज इक्वल टू ek प्लस EP, okay. I am erasing, writing is over. Then come to point, it is how much, ek is equal to 0 plus mgh, so it is mgh. फर्स्ट केस आपको कितना मिला, mgh. फर्स्ट केस mgh मिल गया. बॉडी कहाँ था, when the body is at A, okay. Come to point, when the position of the body, case 2 position of the body is at B, okay. So when body falls, suppose during falling time it covers distance x, so according to equation of motion, third equation of motion, v square minus u square is equal to 2s, using equation of motion, थर्ड इक्वेशन ऑफ मोशन कितना हो गया, यहाँ से u 0 हो गया, ये g हो गया, s x हो गया, तो कितना हो गया, v स्क्वायर इज इक्वल टू 2gx यहाँ हुआ. तो काइनेटिक एनर्जी कितना हो गया ना, हाफ mv स्क्वायर, हाफ mv स्क्वायर कितना मिला बेटे, यहाँ 2gx. सो 2 कटा कितना आया, mgx. ये दिस इज अबाउट काइनेटिक एनर्जी. इसी पॉइंट में पोटेंशियल एनर्जी कितना होगा, बता रहा हूं, एट बी पोजीशन में, EP इज इक्वल टू हाउ मच, हाइट. जब पोटेंशियल एनर्जी निकालेंगे तो फ्रॉम द अर्थ सरफेस लेना, तो यहां तक हाइट कितना, h माइनस एक्स. सो mg h माइनस एक्स. अभी टोटल एनर्जी कितना हुआ, ET और EM इज इक्वल टू ET इज इक्वल टू EK प्लस EP. EK कितना हुआ, mgx. यहाँ कितना हुआ, mgh माइनस एक्स. अभी थोड़ा स्लो कर देते हैं, सब इजी था. तो mgx प्लस mg ब्रैकेट खोल दो, mgh माइनस mgx कितना आया, mgh. इक्वेशन 2. बॉडी जब ए में था टोटल एनर्जी mgh था, बॉडी अभी बी में है, टोटल एनर्जी mgh। अभी कर देंगे केस 3 8c, सेम थिंग यूजिंग द इक्वेशन, थर्ड इक्वेशन ऑफ मोशन। आप कितना लेंगे, सपोज आप वेलोसिटी दूसरा कुछ ले लो, v1 u1 स्क्वायर 2s। अभी कितना हुआ, u इजिकल टू 0, a इजिकल टू g, s इजिकल टू h। एस हो गया एच, बॉडी कहाँ था, यहाँ, तो ये हो गया, कितना हो गया, u1 दो 0, v1 आप अगर लेते हो तो कितना हुआ, v1 स्क्वायर 2gh, तो यहाँ कितना हो जाएगा, इतना, तो 2 को होता, यहाँ कितना हो गया, h, x जगह में h हो गया, x यहां तक था, ये टोटल हाइट h है, यहां तक h माइनस एक्स। अभी कितना होगा, EP इजिकल टू कितना हो गया, EP कितना होगा, हु कैन से, अरे हाइट 0 हो गया ना, तो mg h हो गया 0, तो 0 ये हो गया 0। अभी टोटल एनर्जी कितना होगा, EM इजिकल टू ET इजिकल टू EK प्लस EP। EK कितना हुआ, mgh, EP कितना हुआ 0, अभी कितना मिला, mgh। बॉडी ए में टोटल एनर्जी कितना था, ET mgh। बॉडी बी में टोटल एनर्जी कितना था, mgh। बॉडी सी में टोटल एनर्जी कितना था, mgh। बॉडी कहाँ था, यहाँ, कहाँ पहुंचा, यहाँ, लेकिन टोटल एनर्जी ट्रांसफर हो रहा है, हुआ। सो व्हाइल बॉडी फॉल्स फ्रॉम ए टू सी, द एनर्जी फॉर्म चेंजेस। देखो यहाँ के कितना था, यहाँ टोटल एनर्जी जी पोटेंशियल, ओके, काइनेटिक एनर्जी 0, ये टोटल एनर्जी जी काइनेटिक। देखो काइनेटिक एनर्जी फॉर्मूला हाफ एम स्क्वायर, लेकिन काइनेटिक हो गया mgh। यहाँ टोटल पोटेंशियल एनर्जी था, ए एनर्जी कन्वर्टेड हो गया काइनेटिक एनर्जी को, बट इन बिटवीन ए एंड सी सम पार्शियल पोटेंशियल, पार्शियल काइनेटिक। सो व्हाट एवर इट मे बी, द सम टोटल ऑफ एनर्जी व्हाइल पासिंग फ्रॉम ए टू सी रिमेन्स कांस्टेंट। Okay, it verifies the law of conservation of energy. Then graph, what is the graph? Suppose you will draw the graph, x axis, y axis, it is the energy, mechanical energy, it is the position or height of the body. Position means height of the body. You can take in meter, centimeter, how as per the system of units. Okay, so body is going to this one means what it is, EP. Body is this one is coming from means it is EK, and this one is total how much, total energy. Okay, I am drawing this one, it is x axis. Okay, so come to point. So that is going on, body is going, height, potential energy, it is kinetic energy, it is total energy. So total energy with respect to position always remains constant. Okay. In some books it is also interesting, potential energy always rising, kinetic energy falls, U falls and converted into. So if you draw the diagram, its nature is in this manner. Okay. Then come to point, what you are getting. Suppose एक नारियल कोकोनट लेते हो, पपिया लेते हो, बॉडी यहाँ था, यहाँ फॉल्स हुआ, तो वहाँ जो था पोटेंशियल एनर्जी था, तो जब गिरा वो काइनेटिक एनर्जी हो गया। काइनेटिक एनर्जी जब हुआ तो गिरा तो क्या हुआ, हीट एनर्जी और साउंड एनर्जी फॉर्म हुआ, बट दैट हीट एनर्जी एंड साउंड एनर्जी डिसिपेटेड टू द एटमॉस्फेयर, सो दैट टोटल एनर्जी ऑफ द इनवर्स रिमेन्स सेम। व्हाई? During the free fall, potential energy decreases, but kinetic energy increases. So total energy of the body remains the same. When it strikes the ground, the kinetic energy of the body is converted into heat and sound energy. Whatever it may be, during the transformation of energy, the total energy always constant, whatever the changes its form. It verifies the law of conservation energy. It is applicable in case of free falling body. Thank you. Have a good day.